Hello there, students from Faith Antioch. Merry Christmas coming up very soon. Last week when I was out there visiting with Mr. Snowdy, we talked about the struggles with point slope form and perhaps the importance of point slope form. I'll be honest, when I was in grade school and high school, I skipped over this, and even as a teacher for a long time, I never felt like there was any purpose for having point slope form. I mean, what is the point when I've got slope intercept form, and that usually works just fine. Well, as you try to find lines in standard form, which I know is something that you have to do, knowing point slope form might help you with standard form. The other thing that's going to help you with is someday when you take AP Calculus, which I know several of you will, we like to have things in point slope form pretty often. And this is something that I feel like I have to reteach my calculus kids on a regular basis. So if I can help you guys a little bit out now by explaining maybe the uses of point slope form and how it would work, I think that might be helpful for you guys and for me for 3, 4, 5 years from now. So anyways, as we're looking at point slope form, understand that point slope form written out looks like this. Y minus y1 is equal to m times the quantity x minus x1. And the key thing here is that the name, is exactly what it sounds like. It is point slope form. So the slope part, well, the slope part would be m. So m is going to be whatever number the slope happens to be. Okay, and now the point part of this, well, the point is that I've got some point at x1 comma y1, okay, as in whatever the x value is, whatever the y value is, of a point that's on my line. So you'll notice that there's an x minus x1 over here. Well, that's whatever the x coordinate happens to be for a point that's on the line. And then y minus y1 over here, well, that's whatever the y value of a point through which the line passes, okay? Now, to put this into practice, key is to just remember the way that it looks. Y minus y1 equals m times the quantity x minus x1. So for example, write an equation in point slope form for the line that has a slope of 3 and passes through the point 27. Well, if I know my point slope form, this is actually a pretty easy thing to do. And I'll rewrite point slope form just so you see it here. And again, eventually committing this thing to memory just like slope intercept form will be a wonderful thing for you. So I've got a slope of 3. So as I write this out, I'll have y minus the y value. The y value will be the y value of the point through which this line passes. Well, that's a 7. So y minus 7 goes over here. And that's going to be equal to m, the slope, which I was told was 3, times x minus the x value of the point through which it passes, which happens to be 2. So if I was asked to write it in point slope form, I would be done. That's it. This is point slope form. This is a line, the equation of a line that passes through the point 2, 7. I've got to be able to read that backwards a little bit. It has a slope of 3. Now, let's say for some reason that you wanted this to be in slope intercept form, which would be y equals mx plus b. Well, if I want that, it's just a matter of cleaning up this expression. Okay, so some kids will even use point slope form exclusively in order to find the slope intercept form. If you can remember this and you get good at it, here's the steps to changing what's in red into the format you see in blue. So first step would be to distribute whatever's outside the parentheses. I'll distribute this 3, which will give me 3x minus 6. On the other side, I still have that y minus 7, but you'll notice that I'd like to have y all by itself to get something into slope intercept form. So algebraically, the next step would be to add 7 to both sides. And I'm going to add 7 to that constant negative 6 that's at the end. So when I'm all said and done, I got y is equal to 3x, so 3 being my slope. My y-intercept then, as I'm in slope intercept form, will be negative 6 plus 7, which is positive 1. So y equals 3x plus 1 would be the same, or an equation for the exact same line, same function, same line, same graph, as that which you see in red. Okay, so point slope form here, slope intercept form here. Now, if I wanted something in standard form, where x and y are on the same side, well, then it's just a matter of taking either of these formats and manipulating a little bit. So I'll take what's in green, keep going from there. I would subtract the y from both sides, and I might subtract the 1 as well to move it to the other side. So I'd have negative 1 is equal to 3x minus y, which you could consider to be in standard form. The x's and the y's are together on one side. Other places when you see standard form written out, they'll have 0 on one side, and then they'll have the x term, and then the y term, and then the constant. Think about adding 1 back to the other side, and there you'd have it. So standard form-ish, okay, depending on what you're asked to do or what your answers are supposed to look like, kind of a personal preference thing. Slope-intercept form here, okay, y equals mx plus b, and point-slope form here. So 3 different formats for the same line with the same information. We'll do another example here. So write an equation in point-slope form for the line that has a point of 1/2 and passes through the point negative 3, 1. So again, same idea. Y minus the y value, that's 1, is equal to m the slope, which is 1/2, times x minus the x value. Now when I'm subtracting negative 3, subtracting a negative, what's going to happen? I'm subtracting a negative, that's going to turn into addition. It's going to be x plus 3. Okay. Now, that'd be point slope form, I'd be done. Let's say I want slope intercept form. Well, I'd distribute again. I'd have 1/2 x plus 3 times 1/2 would be 3/2. And I got y minus 1 over on the other side. Then to get y by itself, I would add 1 to both sides. So when I add 1, I'm adding 1 to 3/2. I'm going to do this in my head for the sake of time. Adding 1 to 3/2, 1 is like 2/2. And 2/2 plus 3/2 is going to be 5/2. So 5/2 would be my y-intercept. Okay. I still have this 1/2 x because 1/2 is my slope. And on the other side, I've got y. So y equals 1/2 x plus 5/2. That would be slope-intercept form for this equation. Okay. Now, what if I want standard form? If I want standard form, I'm actually going to back up to this guy right here. Okay. What you think about this one? So standard form, I had y minus 1 equals 1/2 x plus 3/2. Now in standard form, one of the things with standard form is you're not supposed to have denominators. You want just an integer coefficient for every term. So I need to get rid of this fact that I'm dividing something by 2. Okay, so what I'm going to do is I'm going to multiply everything by the common denominator. Least common denominator of all these guys would be 2. So I multiply everything by 2. Here's what happens. I'm going to have 2y minus 2 is equal to 2 times 1/2 is 1, so it'll be just x. And 2 times 3/2 is going to be 3 because the 2's will cancel. Then I would rearrange this to get the x's and y's together on one side. So I would probably, I'm going to add the 2. I'm going to subtract the 2y. So I'll add the 2 and subtract the 2y. Which would give me 0 is equal to, and again, I'm having 0 on one side, doesn't mean you have to, you could have a constant over there instead, but I'm going to have x minus 2y plus 5, and that would be a standard form equation. Or again, could you have negative 5 over here as equal to x minus 2y? Sure, of course you could. But those would be 2 different versions of the standard form equation for that line. So, I got one more example for you, just to show you something else. So again, let's go point slope form. Y minus negative 2 means it's going to be y plus 2. Okay, I hope you caught that. Is equal to m the slope, that's negative 4, times x minus the x value. Well, x minus, notice the x value here is 0. So x minus 0, I probably don't need to put that, but I will just to show you that it's holding its place. So as I simplify this expression then, I'm going to have y plus 2 is equal to negative 4x. Okay. And then to put it in, if I want it in standard form, I'd probably add 4x to this side and have 4x minus, or 4x plus y, plus 2 equals 0 or equals negative 2. Either way, it'd probably be okay. Just depends on what your teacher's looking for. If I wanted it in slope-intercept form, I'd just be subtracting the 2 from both sides. And I'd have y is equal to negative 4x minus 2. So any of these formats is okay. It all represents the exact same line, the same function, the same graph. It's just written in 3 different formats, and it just depends on what it is that you're looking for. Each of them has their uses and their purposes, so hopefully you can be comfortable working in any of those 3 formats. So good luck. If you've got questions, please feel free to leave a comment in the section below.